Hi everyone, this is coming to you from Education for All. We continue to solve problems on the infinitesimal calculus. We are looking here at limits. As we stated in one of our previous videos, that this idea of limit is the backbone of calculus. That's why when you derive a function for this limit, you arrive at a function that is called a principle, which is the fundamental principle of calculus. So that is what we are going to apply to solve these three problems. Problem number 1 states that prove from first principles that the derivative of 6x, the derivative of 6x is 6. Number 2 says, prove from first principles that the derivative of 4x squared is 8x. The third one says, f of x is equals to ax squared, where a is a constant. That's this a here could be any number. It's a constant. It could be any number. That's the meaning here. A is a constant. This could be any number. Where a is a constant, prove from first principles that f prime x is 2ax. In all of these problems, we are asked to find the derivative. This f prime x is another way of writing derivative, f prime x. This means when you see this f of x, you see a prime here, it's the same as the derivative of a function. So let's start with the first one, which says prove from first principles. We have to prove from first principles, which means we are going to use the fundamental principle of calculus. So doing that, if you could remember this diagram, this is a function. This function, we can call it any function, just f of x. Y equals f of x. This graph. You need 2 points for you to be able to calculate the gradients. Yeah? You need 2 points. Remember this? You have your x here, you have your y here. I hope you remember this. If this is your x, this is your this distance from here to here, we'll say is h. So this will be x plus h, this distance, this small displacement. And here you have your f of x, which is your y, and this is your f of x plus h. F of x plus h. Right? So from first principle, to find the gradients, which we can also say m, is the same as f prime of x for now. Later on, you'll also come to realize that the gradient is also written as the x the y, the x. All these mean the same thing. M gradients, f prime x gradient, the y, the x is gradient. Or you call it derivative. Derivative, T-I-V-E. They are all the same thing. It just depends which one the question is referring to. But they're all the same. Right? So, from the first principle, It's something we've already derived. We just want to make use of it here. We know that the limit as h tends to 0, f of x plus h minus f of x divided by h. We know this holds from first principle. This is what you have. So this is what we will be using to solve these problems. When they say prove from first principles that the derivative of something is that, this is the rule of the first principle. Now, let's carry on. Here we are given 6x. So we are looking now at number 1. The gradient m is equals to the limit I'm looking at number 1. The gradient, which is m, you have the limit as h tends to 0. In this case, you're having f of x plus h. So you're having your f of x plus h, which is 6. Let's just put it like this for now. F of x plus h, which is now 6 into x plus h minus 6x. We are using this. Yeah, I don't want to write it again. All over h, because we are just applying this straight. Yeah. F of x plus h, because the x here, originally it was 6, but this x has moved a little bit. Yeah, from here to here. This distance is what is called h. This distance is what is h. So that is the small movement, because in calculus we deal with this infinitesimal. It means smaller numbers. That's the meaning of infinitesimal. Smaller, very small numbers. So all we need to do here is to apply algebra. That's all is left. Once you are able to represent this problem into this format, all you need to do is apply your knowledge of algebra to simplify things, because this is the rule of the first principle. So in that case, you have here m. This is the limit as h tends to 0. This will be 6 times x, will be 6x, 6 times h plus 6h minus 6x all over h. So you can see that 6x minus 6x, they cancel each other. Yeah, 6 minus 6 cancel each other. So what is left now is limit as h tends to 0, 6h all over h. So you can see that the h again will cancel. So what is left? We only have 6. So this one is solved. That's all you need to do. When you're asked to prove from first principle, this is what you do. So let's move on to question number 2. Question number 2, I want to leave this and this. I only need to take off this just for you to get the idea of solving these problems. Question number 2 says, prove from first principles that the derivative of derivative of 4x squared is 8. Use first principle. This is the first principle, the rule of the first principle. This is it. So this is what we are using. We already have the limit. So this is 4 plus h. So there you have 4x plus h, because this x is what displaces a distance, delta x, small displacement. So the x will move this amount, right? So you have 4x plus h, but x has squared here. So don't forget your squared, minus f of x. And you know now all of the f of x, 4x squared all over h. So this is how you go about it. Interpreting the problem is the main issue here. Solving it, you already know this function here. So you just substitute what you have and then you simplify. Yeah? Because x has squared here, that's why you see this squared in the f of x plus h. But the x has squared in this case, so you have to include it because even your function has 4x. See that? So all you do here, again, you apply algebra. So you expand this problem, this one here. So that is, let's expand this first. When you have 4x, forget about the 4, you're having x plus h all squared. So the 4 will be out because you multiply everything. So this will give you x squared plus 2hx plus h squared. So this is what you get. When you expand this, this is what you get. Then you'll have minus 4x squared all over h. And this will be m is equals to the limit as h tends to 0. Then you have this. So now if I remove these brackets, this is going to be 4x squared. This is going to be 8hx, and this is going to be 4h squared. Yeah? So I'll take out this. This 4 will be here. This will change to 8. And this will be plus 4. So this is what you get, right? So again, here, you can see that the 4x squared will cancel this. 4x squared minus 4x squared is 0, get 0. So what is left here is 8hx plus 4h squared, right? So now let's do something. We have h on these two elements, so we can factorize. So this will give us m is equals to the limit as h tends to 0. So we'll have h factorized. So this now will become 8x plus 4. If you factorize the h, it will be 4h will remain. Yeah, still one h will remain, and you have your h at the bottom. If you expand, you will get 8hx plus 4h squared. So what do we want to do here? What do we want to do? We want to show that the derivative of 4x squared is 8x. That's what we are trying to show, right? So from here, we know that h will cancel h. So then you will have the limit as h tends to 0. This h, you're going to cancel this h here. So it will be 8x plus 4h. But then, what did we say? When this h keeps reducing. In other words, if you put another point here and you draw a line here, you put another point here and you draw a line here, you put another point here, you draw a line to join this, it will come a time when the line you get will just be a tangent to this point, that is, just touches that point. And at that point, when it touches it, the gradient is 0. We don't want that, the gradient to be 0. It's not going to give you any good interpretation. So that's why we just keep on reducing this h until it approaches to 0. Instead of, that's the whole principle of this fundamental principle of calculus. We don't want this h here to be 0. We already explained that, because this is what Isaac Newton was trying to do when he was studying motion of the planets. When h is 0, then you will arrive at nothing, right? So this is what we are trying to do here, just to explain this diagram so that you can understand what we're doing. Right. Anyway. So if h is 0, in this case here, this will be 0. When h is 0, 4 times 0 is 0. So this now will be remain 8x, which is what they asked to find. When this value approaches to 0, it's not actually 0, but when it approaches to 0, it becomes negligible. It becomes nothing in the equation. So the answer remains hx. Thank you for watching. Bye-bye.